So now we can use the identity matrix to find a special matrix we call the inverse. And the inverse is going to be needed to solve equations eventually. Because in matrices, there's no such thing as division. So in order to do this, we need to use the inverse of multiplication to actually do this. So the inverse itself is what we call A inverse. And it exists only if these two conditions are met, or this condition is met. A must be a square matrix. So first thing, in order to have an inverse, A must be a square matrix. And if we multiply the inverse, or the original matrix by the inverse, we get the identity matrix. So in order to find an inverse, I'm going to use those metric equations that we talked about earlier. Here's what I'm going to do. I have a matrix at 4, negative 1, negative 6, 2 for A. I want to find its inverse. So to find the inverse, the first thing I do is I set up these equations like this. Notice I'm multiplying this original matrix, and I multiply by another matrix with the letters A and C, B, and D. Notice the order of A and C and where B and D are. You have A and C in the first row, B and D in the bottom row. And it equals the identity matrix 1, 0, and 0, 1 for a 2 by 2. So when we do this and we start multiplying, we do a row by a column. So the first element looks like this. It's 4A minus 1B. The other element in that row, if we go to the next one, is 4C minus D. Down here in this bottom row, we do that one. We have negative 6A plus 2B. And the next one would be negative 6C plus 2D. So we set this equal to the identity, which is 1, 0, 0, 1. And we're solving equations now. So the first equation I'm going to solve is 4A minus B is equal to 0. 4C, that's equal to 1. 4C minus D is equal to 0. Negative 6A plus 2B equals 0. Negative 6C plus 2D equals 1. Notice I have two unknowns in this equation, A and B, but I also have two equations, so I can actually solve this like a system. In order to solve it, I'm going to use elimination. And I'm going to eliminate the B variable because I have opposite signs. I'm going to multiply this red equation by 2. When I do that, I get this. 8A minus 2B equals 2. Minus 6A plus 2B equals 0. If I'm eliminating 8A minus 6A, that is 2A. The B's eliminate. I'm left with 2 minus 0, that's 2. Divide everything by 2. A is equal to 1. So I know the variable for A is 1. Because I know A is 1, I can go back and substitute into any one of these equations. I'll substitute into 4A minus B is equal to 1. So I'll take the equation 4A minus B, and I'll plug in A equals 1. 4A minus B is equal to 1. So we have 4 times 1 minus B equals 1. So that's 4 minus B is equal to 1. I'm going to move B over, make it positive, and I'll bring the 1 over, make it negative. So what you have is B is going to be equal to 3. And then to get the other one, I'll do the exact same process. I'll try to eliminate a variable. So I'm going to eliminate the D variable because they have opposite signs. I'll multiply the top equation by 2. And so here I get 8C minus 2D equals 0. Minus 6C plus 2D is equal to 1. These cancel. 8C minus 6C is 2C. That equals 1. Solving for C, divide everything by 2. I get C equals 1/2. Now that I know C equals 1/2, plug it back into any equation. I'll take the top equation, and I'll do 4 times C minus D is equal to 0. So plugging in for C, 4C times 1/2 minus D equals 0. Half of 4 is 2. 2 minus D is equal to 0. And I can move D over, make it positive. So D is equal to a positive 2. So the inverse matrix, which we call A inverse is equal to your A variable. Your A variable here is going to be 1. The B variable will be 3. The C variable, 1/2. And the D variable is actually 2.